Good morning, students. Today we are going to see problems related to the fin. First of all, note down the problem. A cylindrical fin is 3 mm in diameter and 3 cm long. Calculate the value of the temperature at fin tip if the fin is made up of first copper whose value of K is 350 watt per meter Kelvin, and second Teflon whose value of K is 0.35 watt per meter Kelvin. Assume that heat loss from fin tip is negligible. Take H is equal to 10 watt per meter square Kelvin and TF means temperature of surrounding is 20 degrees Celsius and temperature of base is 120 degree Celsius. So they are asking you to find that the value of the temperature at the fin tip, and they are giving two materials. First one is the copper and second one is the Teflon. First of all, we are writing the given data. So they are given diameter 3 mm. We are going to convert this in meter. Next, second they have given length. Now first part they are asking you to find when there is a copper fin. So for first case considering here copper fin. So for this copper fin we have to find, and we have the formula for the temperature distribution. Theta upon theta b is equal to cos of h of m into L minus x upon cos of hyperbolic of ml. Now for negligible heat loss from the fin, for the tip we are considering x is equal to L. Now when there is a x is equal to L, for this our condition theta upon theta b cos of h of m of L minus x upon cos of h of ml. So it becomes cos 0 is 1. So 1 upon cos of hyperbolic of ml. So as per the end condition for negligible heat loss from the fin. So for this condition we are putting the value of x is equal to L, and from this we are modifying the formula theta upon theta b is equal to cos of hyperbolic ml. So as we are finding this value, first of all we are going to find out this m value. M is equal to under root HP by K. So for this they have given, we know the value of H, and for rod we can write perimeter is equal to pi into D and area pi by 4 D square. So formula modifies upon K into D. So this M value we have to calculate. They have mentioned in the problem value of H they have given. So it is 10. H is equal to 10 watt per meter square Kelvin. And next they have mentioned the value of K 350 and diameter we have converted 0.003 meter. So we are getting the value of M is 6.172. Now we have found the value of M, but they are asking you to find temperature at the end of the L. So we have to substitute this value in this theta of L is equal to, they have given the temperature at the base 120 minus temperature of surrounding, they have given 20 upon cos of hyperbolic value of n 6.172 into value of length 0.03. So after substituting the values and calculating on the calci, we are getting theta L is equal to 98.31. So temperature of at the end of the L plus temperature minus temperature of base, we are getting 98.31. So we know the surrounding temperature. So temperature of L, we are subtracting the value of temperature of surrounding 20 from this here subtraction means we are going to add over here. So we are getting value 118.3 degree Celsius. So this is the temperature when we are using the copper material. Now second material they have given. They have given Teflon tape, Teflon film. So again for this Teflon film we have to find the value of M, because if you observe this formula of M as we have modified under root of 4H upon KD. So as value of K for Teflon is different, so first we have to find the value of M. So M is equal to under root 4 into 10 and K value they have given 0.35 and diameter 0.03. So from this we are getting the value of N 195.2. So once you got the value of M, you have to substitute again this formula as we have modified. Theta L is equal to 120 minus 20 upon cos of hyperbolic value of M 195.2 into length 0.03. So we are getting the value 0.57. So as we are finding theta L is equal to 0.57, but theta L is again TL minus TF. Okay, so this value is 0.57. So TF value is 20. So we are going to add 20.57. So these are the values of the temperature at the fin tip. So when material changes from this problem, we can easily observe that as material is changing, first we have used the copper material. So for copper material, value of M is different, and as we are substituting this value of M, we are getting temperature at the fin tip which is 118.3. But when we change the material, we are using the Teflon. From that, the value of M gets different, and as we are substituting in this equation for theta L is equal to base temperature minus surrounding temperature upon cos hyperbolic ml. So we are substituting the value in this equation, and we are getting the temperature when Teflon is using TL is equal to 20.57. So you can see both the temperature are different as we are using the different material. So this is first problem we have discussed. Now we are going to discuss second problem. Note down, a metallic plate is maintained at 250 degrees Celsius. A 2.5 centimeter diameter aluminium rod protrudes 10 centimeter from this plate. Rod is exposed to atmosphere at 20 degrees Celsius with H is equal to 15 watt per meter square Kelvin. Take value of K is 200 watt per meter Kelvin for aluminium. Assuming the rod as a fin insulated at end, calculate heat loss by rod and also calculate efficiency. So this is the problem they have mentioned. Now, first of all, we are going to draw the figure of fin. So first of all, we have wrote down the given data. Diameter D, they have given 0.025 meter. Length they have mentioned 0.01 meter. Value of K 200 watt per meter Kelvin. Temperature of base they have given 250 degrees Celsius. Temperature of atmosphere 20 degrees Celsius. Value of H 15 watt per meter Kelvin. Now they are asking you to find the efficiency, and they have given the end condition. Assume the rod as a fin insulated at the end. So we have the efficiency formula. Efficiency is equal to tan of hyperbolic ml upon ml. So in this equation, we have to calculate first value of n, because they have given the value of L, they have given here, value of H they have mentioned. So whenever we are going to calculate the efficiency, we require the value of M. So for this, first we are going to calculate the area pi by 4 d square, which is equal to pi by 4 into diameter 0.025 square. So it becomes 4.9 into 10 raised to minus 4 meter square. Next we are going to calculate perimeter, that is 5 into d, which is equal to 3.14 into 0.025. So value becomes 0.78 meter. So we have calculated cross section area and perimeter, because M is equal to under root HP by KA. So in this equation, value of H is given, which is 15. Perimeter we have calculated 0.78. Value of K 200. Value of cross section area we have found 4.9 into 10 raised to minus 4. So we are getting the value of M is 3.46 per meter. Now we are going to substitute this value in efficiency formula. So after substituting the value of M in this equation, we are getting the efficiency 0.996, which is equal to 99.6%. So this is the efficiency of the frame. First of all, we have to plot in diagrammatic manner which things they have mentioned. We have written the given data diameter. They have given the diameter of the fin, they have given the length of the fin. Also they have mentioned the conductivity of this fin, base material, temperature they have mentioned. Also they have given value of H, means convective heat transfer coefficient value. So we have written all these values also. They are asking us to find out the efficiency. So as per our efficiency formula, efficiency is equal to tan of hyperbolic of ml upon ml. So as we know the value of length, but only unknown is m. So see the difference between this h and this h. This is the hyperbolic of ml, because whenever you are going to use the calci, you have to take the tan hyperbolic ml, not you have to substitute the h value. Okay, so whenever you are going to calculate the value of m is equal to under root hp by ka. So substitute the values. First we are going to find out the value of m, and once you got the value of m, you are going to substitute this value of m in this equation. Length they are given, and you are getting the efficiency of the fin is 99.6%. So this is all about the today's lecture. Today we have seen two problems. In first problem, they have given two different material whose thermal conductivity is different, and for that we have calculated temperature at the end of the fin. And in this second problem, they have given all the condition and asking you to find the fin efficiency. So this is all about today's lecture. Thank you very much.